Hi everyone! In this video I will be discussing my findings from Lab 3 Black Hole. The goals for this lab are to update the code to reflect the trajectory of a star orbiting a black hole, to analyze the motion of a star to find the net force on the star, and to estimate the mass of the black hole. The principles used in this lab are Newton's second law, which states that the net force can be calculated from delta P divided by delta T, and the gravity formula, which states that the force of gravity can be calculated by multiplying the gravitational constant by the mass of two objects and dividing all of that by the radius squared. In order to find what we are looking for, we have to update the code. The values of g, star.m, and delta T are given. To calculate our momentums, we multiply the mass of the star times the respective velocity. Our deltas are calculated by taking the final value minus the initial value. We set dp dt equal to delta p over delta t, and from Newton's second law, we know that this is equal to the net force. We know that p hat can be found by doing p initial divided by the magnitude of p initial. Dmag p dt is found by doing the magnitude of p final minus the magnitude of p initial all over delta t, and dp dt parallel is found by doing dmag p dt times p hat. The rest of these calculations can be deduced through knowledge of physics principles. To calculate MBH, we use the gravity formula, but we arrange it to where M1 is isolated by itself. We use the position of the star as the radius since it is given to us that the black hole is located at the origin. When we run the code, we see that most of the numbers are close to 1.5 times 10 to the 34th, so we can just use the second value as a good estimate for the mass of our black hole. Looking closer at the model, the orange arrow represents the net force, the magenta represents the perpendicular component, and the blue represents the parallel component. So what does this all mean? The lab asks us to discuss how the net force and its parallel and perpendicular components differ from the rate of change of momentum and its parallel and perpendicular components. For the momentum principle, we know that Fnet is equal to its respective dp over dt. However, they differ in how they are calculated. Fnet is calculated through the gravity formula, and dp dt is calculated through the following logic. The derivative of velocity with respect to time is acceleration, so force equals mass times acceleration. So it follows that the change in momentum with respect to time can be calculated by multiplying the mass times the acceleration. The lab then asked for a different scenario. It asked that if our original black hole was replaced with a new black hole, would we be able to find a different mass than what we previously found? We would not be able to find a different mass because all of the other components from the gravity formula stayed the same, so our calculation would go unchanged. So after completing the lab, it is evident that the mass of an unknown central object can be calculated through orbital trajectory, and also that we can deduce the behavior of complex systems such as black holes through simple models that we do through code.